For decades, enterprise security relied on a single defining logic: keep the bad guys out. Administrators built digital fortresses defined by strict physical boundaries. Consider a standard mid-sized enterprise, 350 employees, all operating entirely within a traditional, locally hosted network model. Looking at this network diagram, the baseline topology is straightforward. We have employee workstations, a local Active Directory, a CRM, and a database, all residing together on the internal network. The entire structure is protected by the corporate secure border. This is the primary line of defense, relying on static packet filtering and physical isolation to control traffic. In this closed loop, identity management is simple. An employee workstation securely queries the local Active Directory, authenticates, and accesses the local CRM. The architecture functions perfectly. But it works under one strict condition: every user, device, and application must remain physically inside the corporate box. Modern business realities break this physical boundary. Organizations are migrating aggressively to software-as-a-service applications and requiring tight external B2B integrations. Suddenly, the business needs to interact with elements situated completely outside its control across the open internet. The rigid internal network is forced to stretch awkward, vulnerable connections across the public internet to reach these external assets. This creates an immediate operational bottleneck. The local Active Directory is designed to authenticate local users for local machines. It lacks a native, secure way to authenticate users for applications it doesn't host. Furthermore, if the organization needs to grant access to a business partner, they are forced into manual provisioning. Administrators must create and manage local network accounts for external employees, a massive administrative burden and a severe security liability. Adopting cloud technologies and external partnerships shatters the physical network perimeter. The organization must completely redesign its approach to identity. When designing a new cloud-integrated system, the very first architectural priority is availability. Authentication services must stay online. Look at the fragility of the legacy design. If that single local Active Directory server fails, the outage cascades instantly. Users are locked out of the internal CRM, and they immediately lose access to the external cloud e-commerce application. Relying solely on an on-premise authentication server behind a local firewall creates a dangerous single point of failure for critical cloud services. The solution is to lift the authentication engine completely out of the local network using an Identity as a Service, or IDaaS, platform. The IDaaS node bridges the gap by maintaining a secure, continuous synchronization with the on-premise Active Directory. This provides highly available, low-latency authentication directly to cloud applications. It operates entirely free from local network bottlenecks or local hardware failures. Achieving true resilience for modern enterprise applications requires decoupling the authentication engine from the physical office space. The second architectural challenge is external trust. The organization needs to securely share identity information with its external business partner. Standard legacy practices, specifically creating local internal accounts for a partner's remote employees, introduce unacceptable risks. It means storing and managing credentials for personnel you do not employ. The definitive secure architectural alternative for B2B integration is federation. Federation links two separate sovereign identity domains that maintain their own independent user directories. Administrators establish a strict cryptographic trust relationship between these two entities. The mechanical workflow is precise. The partner authenticates their own users on their own systems. The host organization then accepts that verified proof without ever transmitting, seeing, or storing a password. This completely eliminates the administrative overhead of manual account provisioning and drastically reduces the host organization's security liability. Under this architecture, security teams stop managing partner accounts and start managing cryptographic trust. This leaves one final technical hurdle. How does the external cloud e-commerce application actually verify the identity and permissions of an employee? The cloud application cannot simply punch a hole through the firewall and query the internal Active Directory database directly. That violates core network security principles. The technology required to solve this gap is SAML, the Security Assertion Markup Language. The process begins when an employee attempts to access the cloud app. That action triggers an authentication request straight to the IDaaS platform. Once verified, the IDaaS generates a sealed cryptographic token, the SAML assertion. It passes this assertion back through the user's web browser. The cloud application receives the token, validates the cryptographic signature, and grants the exact level of access dictated by the assertion's internal claims. SAML acts as a secure cryptographic passport, allowing identity and authorization data to travel safely across untrusted internet space. We now have a fully upgraded enterprise architecture. IDaaS, Federation, and SAML are active, functioning components. The rigid corporate boundary is no longer the defining security feature. The true border now wraps dynamically around the identity providers and the individual access tokens, moving wherever they travel. A user's physical location, whether sitting at a corporate desk or working from a remote coffee shop, no longer dictates their network access. The tactic of relying on physical egress filtering or blocking IP addresses at a firewall is replaced entirely by granular, identity-centric access control. The corporate network border no longer protects the enterprise data. The identity provider does. For senior cybersecurity leaders, this technical implementation is only half the equation. We have to view this shift through a managerial lens. Technical controls like SAML, Federation, and IDaaS are useless if deployed in a vacuum. These architectures must align directly with business priorities. They are built to accelerate partner integration speeds and guarantee extreme uptime for revenue-generating applications. Modern operations move with massive scale and velocity. Security architectures are required to enable this continuous global motion. Managing digital trust relationships across disparate systems and independent organizations remains the hardest yet most vital task for a security architect. The impulse to build thicker physical walls is obsolete. Mastering federated identities and decentralized trust is the defining characteristic of modern enterprise security leadership.